Hello, AAG students, back at it, right? We're still working with special right triangle rules, and we're incorporating that into area and perimeter. So I want to use that to try to find the area and perimeter of trapezoids, okay? We're going to use our trapezoid formula each and every time, and the perimeter will be the sum of the outside lengths. Now, with that being said, I have to remind you of something important. So I'm going to zoom into this trapezoid we have here. So if you think back to earlier chapters that we've covered this year in geometry, okay, if you know that it's a trapezoid, right? I have at least a pair of parallel sides. There they are, highlighted. Then we should treat the other lines coming through here, like for example, this line right here, we should treat that like a transversal. We did this back in that section, right? But, you know, here we have another transversal over here. The reason why I bring that up is because we have an angle here of 135 degrees, and these two angles are same side interior, which means this angle right here will be the supplement of 135, right? So it's going to be supplementary to that. 180 minus 135 is going to leave us with 45 degrees. I like that number, okay? Now, since this is an isosceles trapezoid, I wanted to mention that to you. Notice, right? This side and this side are the same, right? So this is going to be an isosceles trapezoid, or basically like a perfect trapezoid. We could technically draw a line of symmetry down and fold everything on this side to the other, okay? So an isosceles trapezoid is one that's perfect, right? All of the sides and angles on one side match the other. So what I'm going to do is put the 45 degrees here, 35 degrees here. Okay, so everything's nice and symmetric, and I think we'll be ready to go here. So just like we did for a parallelogram, I want to draw my height perpendicular to the base. Okay, as a matter of fact, I'm going to say perpendicular to the bases. All right, we'll come back to that in a minute. Okay, now if you wanted to, you know, you could draw it on either side, but these two heights that I drew in red are congruent, are equal. Okay. And think about what we just did here, right? If this is 45 degrees and that's 90, then guess what? Then that's 45 as well. Okay, so what we've done is we've cut triangles on the sides here that are 45, 45, 90. Okay, in the middle here, although it looks like a square, I don't know if it's actually a square, but I do know it's a rectangle. Come back to that also in a minute. So what I'd like to do is just simply focus on one side of this, okay? So first and foremost, I'm going to focus on this triangle on the right, just by itself, okay? And let's try to remember that in any 45, 45, 90, this is the side that is usually x radical 2, then your legs would be x's. So as a reminder, we are going to divide by radical 2 and find the other two lengths, which are equal, okay? And as I stated in the last video, I'm not going to keep reviewing how to rationalize denominators. We've done that for a while now, okay? So 6 divided by radical 2 and rationalized, now watch how I draw this, okay, is going to give us 3 radical 2, okay? But I'm going to draw this little, like, you know, arrow and line looking thing so that I know 3 radical 2 is only between the two arrowheads, okay? We just said it's a 45, 45, 90, so that is also 3 radical 2. Now, boys and girls, this triangle here on the right is congruent to this triangle on the left. They have the same angle measures, right? They even have the same hypotenuse, which means they have the same legs, right? So that height of 3 radical 2 should be the same throughout. So let me go ahead and put 3 radical 2 over here as well. Guess what? 3 radical 2 here on the bottom as well. Okay? 3 radical 2. Good. All right. So, wait a second. We're missing a length on the bottom here. And, hold on a second. Can't we drag that down? Right? We did say earlier it's a rectangle, but now that I can see all of my lengths, hold on a second. Oops, just moved it out of the way. Now that I can see all of my side lengths, this is also 3 radical 2. I'm going to drag that down from the top. So, believe it or not, if you look in the middle here, it is in fact a square. Doesn't always happen, but in this case it does. All right, now that took a few minutes, all right, to label all of our sides and all of our angle measures. So now let's go ahead and try to finish this up. Let's put this all together. Okay, perimeter. Perimeter is the sum of all of the outside lengths. So I'm not going to include anything on the inside. Okay, but if you need to, maybe you just you're on your iPad and you highlight the outside. Okay, only include those lengths out there. Okay, so here we go. I'm going to say perimeters. Maybe I'll start here and I'll go clockwise. Okay, so let's go 3 radical 2 plus 6 plus, now hold on guys, I want to shorten up my steps here. So what would be the full length of this base on the bottom here? Well, it's 3 radical 2 plus 3 radical 2 plus 3 radical 2, so that is 9 radical 2. Okay, so I'm just going to shorten up my steps there, right? So let's see, that's 3 radical 2 plus 6 plus the longer bottom, 9 radical 2 plus another 6. Now, after doing extensive work with our radicals, guys, hopefully you'll recognize that we have some like terms here, right? So let's finish up by adding the like terms, but not adding the unlike terms. 6 plus 6 is 12. 3 radical 2 plus 9 radical 2 is 12 radical 2. Not bad, right? And that was kilometers or kilometers, whatever you prefer. All right, next, let's get to the area. Okay, now 1/2 times base 1 plus base 2 times the height. Okay, now we're going to notice some similar numbers in here, right? But remember, the bases are base 1 and base 2. The bases are the parallel sides. So we have them here, and the height is the perpendicular height between those two bases. Actually, I'll leave that circle. Okay? All right, so here we go. So now I got to substitute my numbers in here, right? So let's say area equals 1/2. Now the smaller base was 3 radical 2. The longer base was 9 radical 2. And the height was 3 radical 2. There's a lot going on here. Okay, so what I'm going to do is this. Inside the parentheses, and this doesn't always happen, but it's nice when it does, I have like terms here. So what I'm going to do is combine that, right? So let's say now we're going to have area equals 1/2 times, in parentheses, 3 radical 2 plus 9 radical 2 is 12 radical 2, and then times 3 radical 2. All right, so let me just kind of slide that down a little bit. All right, so here we go. Again, we're going to multiply 1/2 times 12 times 3 in any order. Okay, if you wanted to, here, 12 times 3 is 36. Cut in half is 18, right? And then radical 2 times radical 2 is just 2. Okay, yes, it's radical 4, but the square root of 4 is just 2. So we will end up with, believe it or not, a nice whole number here, right? 36 kilometers squared. Okay, so there is our area. All right.